How did Vikings navigate without a compass? The coastline disappeared 3 hours ago. Now there is nothing around the ship except gray water, low clouds and waves moving beneath a square wool sail. No compass points north. No chart shows hidden rocks. No clock measures how long the ship has been drifting. And no one aboard can know their exact position. Yet the man controlling the course does not appear lost. He watches the angle of the sunlight through the clouds. He studies the wind against his face. He notices the direction of the waves beneath the ship and the birds crossing overhead. Then he makes a small adjustment to the steering oar. The crew continues west. Viking sailors crossed the North Sea, traveled deep into European rivers, reached Iceland and Greenland, and eventually arrived in North America centuries before GPS, modern charts or the widespread European use of the magnetic compass. So how did they find their way? The answer was not one secret instrument. It was an entire system built from memory, experience, and close attention to a world most modern travelers have learned to ignore. To understand Viking navigation, we first need to correct one important image. Not every voyage involved crossing an empty ocean. Most water travel followed coastlines, fjords, rivers, and island chains. When land remained visible, sailors could navigate by recognizing mountains, headlands, islands, beaches, settlements, and unusual shapes along the coast. A cliff viewed from the sea could be as useful as a road sign. A narrow opening between two islands could mark the entrance to a safe route. A mountain with a distinctive shape could tell an experienced sailor exactly where the ship was. Lookouts watched constantly for these landmarks, especially when sailing close to shore. The Viking Ship Museum notes that most journeys followed coasts, rivers and streams, where visual knowledge of the landscape was essential. Vikingskipsmuseet, 1. But recognizing a coastline is not as easy as it sounds. Land looks different from the sea. A mountain that dominates the landscape from one direction may disappear behind another ridge when viewed from a ship. Islands can appear connected to the mainland. A familiar bay can become unrecognizable in fog or low light. Sailors therefore built mental pictures of routes. They remembered which headland appeared first. How one mountain lined up with another. Where the water became shallow. How long it usually took to travel between two known points. This knowledge was not stored in printed navigation manuals available to every crew. It lived inside experienced people. A skilled navigator could describe a journey as a sequence of observations. Keep the mountains on your right. Sail until one island disappears behind another. Cross the open water for half a day. Then look for a dark cliff rising beyond the horizon. Some later written sources preserved sailing instructions in this practical form. They described routes through geographical features, travel time, and the position of islands rather than through modern coordinates. Vikingskipsmuseet, 2. This made experience one of the most valuable resources aboard the ship. A vessel did not merely need someone strong enough to control the steering oar. It needed someone who understood distance, course, speed, wind, and the signs provided by nature. The navigator had to continuously compare the present journey with previous voyages. Does this wind normally push the ship toward the coast? Are the waves striking from the expected direction? Should land already be visible? Has the ship traveled faster than usual? Without an exact position, sailors could still estimate where they were through a method similar to what is now called dead reckoning. They began from a known location. Then they estimated the direction traveled, the ship's speed, and the amount of time that had passed. From those estimates, they formed an approximate position. But each estimate contained uncertainty. If the ship moved slightly farther south than expected, the error might seem harmless during the first hour. After an entire day, it could place the crew far from its intended landfall. Wind made this even more difficult. A ship does not always travel exactly where its bow is pointing. Wind, waves, and currents can slowly push it sideways. A navigator therefore had to feel what the ship was doing beneath him. The surface waves might be created by the local wind, but deeper ocean swells could continue arriving from another direction. Experienced sailors could use these repeating movements as a kind of natural reference, especially when clouds hid the sky. The wind itself also had a history. A sailor might remember that a particular wind normally accompanied certain weather or produced a recognizable sea state. Navigation was not a sequence of occasional measurements. It was continuous observation. The sun was one of the most useful guides. Sailors could observe where it rose, how it moved across the sky and where it reached its greatest height. Around midday, the sun's position could help identify south, while its height could provide information about latitude. A navigator did not need to calculate latitude using modern numbers. He could compare the sun's height with what he remembered from a familiar route. If the midday sun appeared lower than expected, the ship might have traveled farther north. If it appeared higher, the crew might be too far south. The Viking Ship Museum describes the sun's position and height as important natural indicators of direction and latitude. Vikingskipsmuseet, 3. At night, stars could also indicate direction. The North Star offered a stable reference for north. But stars were not always available. Many voyages occurred during the warmer months, when northern nights could remain too bright for reliable star observation. Clouds, fog and storms could hide both the stars and the sun for days. That is why Viking navigation could never depend on one celestial object. What happened when the sky disappeared? The crew searched for other evidence. Clouds sometimes formed above land before the land itself became visible. Birds could offer clues because some species traveled only limited distances from the coast. A sailor observing their direction in the morning or evening might infer where they were feeding or returning to rest. Whales could indicate productive currents. Seaweed, drifting wood or changes in water could suggest nearby land or a river flowing into the sea. Closer to shore, navigation involved more than sight. Sailors might hear colonies of seabirds before seeing cliffs. They might smell smoke from settlements. Fresh water flowing from land could alter the water near a coast. The Viking Ship Museum describes this as navigation through nature and the senses, combining birds, animals, clouds, smells, sounds, currents and remembered landscapes into one mental picture. Vikingskipsmuseet, 4. Depth was another source of information. In shallow waters, a crew member could use a pole, sounding rod or weighted line to check how far the bottom lay beneath the ship. This did more than prevent the vessel from running aground. Experienced sailors could recognize underwater landscapes. A gradual change from deep to shallow water might indicate an approaching coast. A particular sequence of depths could help identify a channel or estuary. Research into early North Sea navigation suggests that sounding rods and lead lines were likely important aids, although the surviving evidence cannot show exactly how consistently Viking Age crews used them. Cambridge University Press and Assessment, 5. Then there is the famous Viking sun compass. Fragments discovered in Greenland and elsewhere have been interpreted by some researchers as parts of devices that may have used a vertical pin and the sun's shadow to indicate direction. The principle is possible. If the path of a shadow is known for a certain latitude and season, a sailor could compare the current shadow with the marked curve and estimate direction. But the archaeological interpretation remains debated. We cannot confidently say that every Viking ship carried a sun compass, or that the objects described as sun compasses were definitely used that way. The same caution applies to the legendary sunstone. Later texts mention a stone associated with locating the sun, and experiments show that certain crystals can help detect the sun's direction through cloud using polarized light. That does not prove Viking Age sailors commonly used such stones for navigation. It is an intriguing possibility, not a complete explanation. The safest conclusion is less dramatic. Instruments may have existed, but navigation probably depended primarily on practiced observation, accumulated knowledge and human memory. Vikingskipsmuseet, 6. For long Atlantic journeys, crews could also reduce danger by treating islands as enormous stepping stones. A route west might take sailors from Norway toward Shetland, then the Faroe Islands, Iceland and finally Greenland. The ship still crossed dangerous open water, but each known island reset the navigator's position. From one confirmed location, the next stage could begin. Sailing directions preserved in medieval sources describe keeping particular islands to the north or south, observing mountain heights and watching for coastal birds and whales near Iceland. Vikingskipsmuseet, 7. Even with all this knowledge, Viking sailors still became lost. Ships missed islands. Storms pushed crews away from their intended routes. Fog erased landmarks. Headwinds consumed food and fresh water while the vessel made almost no progress. Navigation without modern instruments was not precise. It was a constant attempt to control uncertainty. The navigator did not always know exactly where the ship was. He tried to know where it probably was, and where it could not be. He combined every available clue. The last known coastline. The direction of the sun. The wind against the sail. The swell beneath the hull. The estimated speed. The number of days traveled. The behavior of birds. The appearance of clouds. The depth of the water. And the memories of people who had survived the route before. That is how Viking sailors crossed enormous distances without a magnetic compass. Not because they possessed one magical secret. And not because they sailed blindly into the ocean. They transformed the natural world into a map. The sky gave direction. The sea recorded the wind. Animals revealed nearby land. Coastlines became remembered sequences. And experienced sailors carried entire routes inside their minds. A modern navigator looks down at a screen to discover where the ship is. A Viking navigator had to look at everything else.